Hello guys and welcome back to my channel, and today over here we will be discussing one of the most crucial topic for technical interview, and that is multi-threading. So multi-threading is one of the core concept of Java, and it is most commonly asked in any technical interview if you are appearing for any SD roles. And in this video tutorial series on multi-threading, I will be publishing 3 to 4 videos on this concept. And all the video will be mostly focusing on the concept of multi-threading that are most commonly asked during the technical interview. Because during the technical interview, there are only a few patterns of questions that are most commonly asked during the interview. So without wasting much time, let's start with this video. So let's first understand that what is actually a multi-threading and why do we need a multi-threading into our program. And we will try to understand it with the help of a simple analogy. So let's assume that you have opened a restaurant at your hometown, and this is your restaurant. So let's say the name of the restaurant is XYZ. And since this is your only startup, so obviously at the very beginning you do not have the funding, and that is why you are the only person who is working over here. So let's assume this is you. Over here within this restaurant you have a single kitchen. So this will be your kitchen, and within this kitchen you have a single burner to cook the food. So obviously you can see, since there is a money constraint, we have some limited resource over here. Now let's take an example that on the first day of your business, at that time, since you are quite new to this business, the total number of customers that you are receiving is quite low. So let's assume only a single customer came to your business for ordering some food. So what you will do, you will go to the counter, take the order, go to the kitchen, prepare the food what he have ordered, and then once you are done, you will dispatch the food to the user. And if the customer is happy with the food, he will leave the counter with a happy note. Now on the day 2, let's assume you got few numbers of customer in the morning. The first customer came, you took the order, went to the kitchen, prepared the food, and then came back with the food and delivered the order to the customer. Similarly, at 11 o'clock another customer came and you did the same thing over here also. Now let's assume in this way you are super successful with your business, and within a week your restaurant got super popular at your location and a huge number of customers are coming to your restaurant for ordering their favorite food. So let's assume that on the next week you got a huge amount of customer at your restaurant, and even then, since you are the only person managing the shop, so what you have to do, you have to single-handedly manage all the order and dispatch the order one at a time. So this process keep on going. So here you can see, since you are single-handedly performing all the activities, so the process is very slow and all your customer is getting very irritated with the slow delivery of the service. So you can see your customers are very unhappy and very soon you will lose your business. So what you did, on the week 3, you appointed few more of your friends to help you in the service of running the restaurant. And with this approach, there is a small benefit, that is, once you are preparing the food at the kitchen, at that time your friend can take the next order from the customer. And in this way, there is a chain of process that is happening simultaneously together, so that none of the customer is in the long waiting queue. And thus, your customer is super happy with the service they are getting from your restaurant. So hopefully this scenario is now clear to you, that how with the help of multiple person helping you within your business is slowly moving to a great success. Now let's understand that with the help of this analogy, how we can connect this thing with the multi-threading process. So if I take a deep look into what are the components that I have defined over here, so here you can see that the restaurant that you are running is nothing but a process of your program. And within this process, you and your friend who are actually doing the task are nothing but the threads within this process. And if you have remembered, within your kitchen means within the process there is only one oven, and this oven is nothing but the critical section of your code, which can only be used by a single thread at a particular instance of time. So this is basically the core concept of multi-threading, and with the help of these 3 concepts, we will implement all the programs on multi-threading. And since this is the core concept of multi-threading, we will solve many problems on multi-threading, and we will see that how we can implement this entire concept with the help of a simple Java code. So without wasting much time, let's implement this process and let's understand that how we can create a multi-threaded application into your system, and what are the different way of creating a multi-threaded application into our program. So without wasting much time, let's get started. But before that, if you have liked this video and if you have liked this concept, please do like and share this video, and if you are new to my channel, Do not forget to subscribe and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So without wasting much time, let's start with the implementation. So since now you have understand the basic concept of multi-threading, let's now see how we can implement that in Java. So before overcomplicating the code with multi-threading, let's start with some basics so that it will be easy for you to understand each and every flow progressively and you can answer any question during the technical interview. So let's start with some basic of multi-threading. So let's create a class called as restaurant, which is nothing but a process of our program. And within this process restaurant, obviously we need a subclass that is called as kitchen where we will do the actual cooking activity. So let's create a subclass called as kitchen, and once we are done with the basic flow, you can understand that how the multi-threading is actually working inside. And within this kitchen, obviously we will have a cooktop which will be helping us to prepare the food. So let's create a function called as prepare food, which is actually the critical section of our code. And within this prepare food method, let's give two printout, and that is food is getting started to prepare and number 2, the food has been prepared, so that we can actually understand that how the execution flow is happening in each and every line. So here we are done. So here we have created a simple function called as prepare food, which is basically the critical section of our code. And within this critical section, we have two simple SOPs, and that is the preparation food started and done. So let's now call this function from the main method and let's see how this thing is interrelated with multi-threading. So first we will create an object of this kitchen class. And from here we will call the function called as prepare food. So let's run it and let's see how this is actually related to the multi-threading process. So here you can see that we are getting two sys out. One is the preparation food started and one is the preparation food done. So what it actually means? So let's assume that at the very beginning over here, one of your customer came to your restaurant, and once the customer has placed an order, you have taken the order, went to the kitchen and then prepared the food and came back and delivered. So this program is actually the analogy of this process. But the question is, where is you in this entire process? Because over here we have not created you separately, and also we have not created any of the friend as a thread to take the order or anything. So let's understand that where is you in this entire process. So what happens, like whenever you run a Java program without any thread or anything, there is always a thread that is involved for running the program, which is called the main thread. And this main thread is nothing but you, who is only responsible for managing the entire restaurant. So over there in our previous slide, if you have remembered, when you have started your business, at that time you were the only person who was responsible for managing the entire restaurant. Similarly, in the program here, the main thread is actually responsible for running the entire program. So here you is nothing but the main thread. So is there any way to see that this program is running by main thread or not? Yes, we have a mechanism to understand that whether this thread is being run by the main thread or not. So let's see how. So over here what I will be doing, within this prepare food method, I will be giving one more sys out, and here I will be printing the name of the thread who is actually executing this process. Which means that it will take the instance of the current thread and it will try to print out the name who have invoked this process. So let's print out this function and let's see who is actually running this entire process. And here you can see this process is running by the main thread. So now since you have understand the basic concept of the thread, now let's move it one step forward. So here for preparation of the food, obviously this is a time consuming activity. So we need to allocate some time for the preparation time. Because here you can see if I just print out this statement, it will print out in a single instance, which means that there is no time taken to prepare the food. But to make it relevant, what we will do, here we will allocate some stoppage time for the food to get prepared. So let's allocate a sleep over here. So a sleep is a function in Java which helps the program to halt over there for a particular instance of time. So let's provide a sleep over here of 3 seconds, which means that here our food will take 3 seconds to get prepared. So what we'll do, we'll give a thread.sleep of 300 milliseconds, which is nothing but 3 seconds. And here you can see this is giving an error because this should be in a try catch block. So let's put this thing in a try catch block. So here if you see, the process is very simple. We have ordered the food, and once the food preparation is started, here it will wait for 3 seconds, and once the 3 seconds is over, means the food has been prepared, it will print out done. So let's run this program and also do observe the output, the way it is getting printed. So here you can see this food is getting prepared, and after the end of 3 seconds, it's printing done. So our process is actually working great. So this was the implementation of the week 1 of our restaurant service. Now, as we have told you, in our week 2, since we are very popular right now in our locality, so the amount of customers that are coming is continuously increasing. So even at that time, if the main thread, that is you, is only preparing the food, then the customer will be very unhappy. So let's see how long does it take to prepare the food for 10 customers over here. So what I will do, I will invoke this function few more times. And let's run this program. So here you can see the first customer came, the order is being prepared and it is done. Again the second person came, order is getting prepared, it's done. So here you can see for each and every step and each and every process, before even taking the order, there is a waiting time of 3 milliseconds for each and every process over here. So obviously the last customer who is in the queue will be super unhappy with the service you are delivering. So we have to upgrade our system and we have to go to the multi-threading approach. So let's see how we will be doing it. So there are two ways by which we can apply a multi-threading into our program. And the two most simple way of doing it is by extending the thread class, and number 2 by implementing the runnable class. So we will implement both of them and we will see what is the pros and cons of each and every method and which one should we implement in our real life. So let's now start with the implementation with the actual multi-threading programming with the help of extending the thread class. So to do that, what we have to do within this kitchen class, we have to extend the thread class over here. And once we extend the thread class, to implement the multi-threading, we have to override one of the simple method, and that is the run method within the thread class. So let's implement the run method over here, and after that I will explain how it will help the program to become multi-threaded application. So we have already learned the concept of the critical section, and in a multi-threaded program, whatever the activities that need to be done by multiple threads should be kept within the run method, which means that preparation of the food, since this is an activity because this is the critical section of the food, so we have to call this function from the run method. So what we will do, we will call this function from here. And let's over here, before calling the function, let's also provide a sysout, and that is the order has been taken, so that it will give you a meaningful output. And thus we are done with the process of multi-threading, and believe me, multi-threading programming is this much easy. Now let's see what we have to do to invoke the multi-threading process. So here you can see, while we are doing a simple code, at that time we were doing kitchen.prepareFood, which means that we were specially invoking the critical section of the program using the object of that class. But in multi-threading, we do not invoke the critical section directly. Rather, what we do, we call a function called as start, which means that once an order is received, we simply invoke the method called as start, which will execute the multi-threading process for us. Now you must be having a question that where is the start method within our program? So basically, start is a simple method that is already implemented within the thread class. So here if you see, if I just go to the implementation over here for the start class, here you can see that within the thread.class, which we have extended over here, within this class we already have an implementation of this start class over here within this thread library. So we do not have to implicitly create a start class over here. So I hope this concept is clear to you. So let's revise what we have done over here. So once an order came to our restaurant, we have created a kitchen object, and then we are invoking the preparation food by kitchen.start, which is internally calling the run method over here, and this run method is also calling internally the critical section of the code, and that is the prepare food over here. So the flow still remains the same, and you will also see the same output over here. So let's run the code. So here you can see, first the order has been taken, then the food preparation has been started, and after that, after waiting for 3 seconds, the food preparation is done. But if you have carefully noticed one thing, this function, that is the run method, is not being invoked by the main class, or rather it is being called by a separate thread that is named as thread 0. Which means that we have already created a multi-threaded environment into our process. Let's now enhance it and let's include few of your friends which are nothing but a multi-threads into our application. And to create this process as a multi-thread application, what we have to do, we have to create multiple threads over here. So let's see how we will create multiple threads over here. And the creation of the multiple threads is also damn easy. What we have to do, we have to simply create another object of this thread class. Since we are already extending the thread class within our kitchen class, so if I just create an instance of this kitchen class, which means that internally we are actually create one more thread within our application. So let's also create the start method with the help of this kitchen 2. Similarly, we will create another object of kitchen 3. So let's clearly understand what we are doing over here. So here right now we are having 3 worker or 3 servants within our restaurant, and all 3 of them will take the order and prepare the food all together with only one critical section within our program. So let's run it and see the output over here, and once we get the output we will analyze that so that it will be easy for you to understand the flow of execution. So let's run this program. And great, here if you see carefully you will notice that, let's take an example that the first customer came over here, an order has been taken by you and you have started with preparation of the food. And once the preparation of the food is going on, the next customer is not waiting for his order to be placed. Rather, what is happening, your second friend, that is the thread 1, has came and also he have taken the order and waiting outside the kitchen for you to complete the preparation of the food. Similarly over here, once these 2 activities are going on, your third friend have taken the order from your third customer and he have also done the same thing. And once all these 3 activities had been done, you can see all this food has been prepared simultaneously. So here if you notice the output carefully, here the process is not waiting for the food to be prepared completely. Rather, once the food is getting prepared over here, the threads are taking the order from other customers. And with the help of this mechanism, obviously you can understand you have reduced the waiting time of your customer into your application. And this is what the multi-threaded application all about. But the process is not as simple as it looks right now. There are a lot of things that are happening internally which we will be learning as we will keep on moving forward with other videos. But let's now understand with some basic, and we will understand that what is the problem over here that we are facing with the multi-thread application. So let's remember this output and let me run this program one more time. So if you see, if I run this program another time, the way the output got printed in our previous time is different the way the output got printed in this time. So here you can see 2 orders has been taken simultaneously and 2 food has been started preparing together. So a particular flow of execution is not happening during the multi-threading process, which means that the sequential execution of the flow will change whenever the multi-threading concept comes to your picture. So if you see, on each and every time when you are running the program, it will give some different output over here. So let's first understand that why it is happening. So what actually happens that whenever we are invoking the start method, means we are telling the thread start the process. And since the execution of this 3 line will happen in a fraction of second, that is even less than a millisecond, all the 3 threads will enter within this run block simultaneously. Which means that right now there is not a particular sequence it is maintaining, but all the process are doing work concurrently, means all at a time. So all the 3 threads will be entering this run method, which is the starting point of the thread together. So that's why we will see in the output 2 order taken has been printed first, means maybe this was printed by the thread 1 and then this was printed by the thread 2. So here thread 2 didn't wait for thread 1 to complete this entire flow of this process. Rather, both of them entered this critical section all together and have printed this order taken together. So I hope this is clear that how multiple threads are getting executed within our program. So to summarize everything, if we are using only a single thread in our process, then only a single thread will enter our critical section, that is within the run method, execute the entire flow sequentially and then come out. But if we are using multiple threads, then multiple threads will go inside the run method together, and all the thread will execute the run method together, and it will try to print out all the statement together, since all the processes are running concurrently, and thus this is called as concurrent processing. So I hope you are clear with the way how a multi-threaded programming is actually working in the real life. Now if I take the comparison of this process with the restaurant thing that we have discussed in our previous slide, over there, if you have remembered, within our kitchen class there was only one oven, and that is why particular cook cannot start the food until and unless the previous instance of the food processing is done. Which means a thread should not enter this complete block until and unless the previous thread is done with the preparation of the food. Which means that once the two order has been taken, these two processes should not start simultaneously. One should wait the complete food preparation to be completed, and thereafter only the next thread should start the preparation of the food. And this is the actual crucial topic of the multi-threading application, that how we can restrict a particular thread from executing a particular block of code and we can make it synchronous. But we will learn that synchronization method in our next video. But here let's complete this program and let's also see that what is the other way of creating a multi-threaded application into our process. So here, rather than creating a thread by extending the thread class, there is another way of creating a thread, and that is by implementing the Runnable class. So let's see how we can change this program. So what I will do, I will comment out this run method and I will delete this thing from here. And here, instead of extending the thread class, I will write implements Runnable. And since this Runnable is an interface, we have to override few of the classes of this interface class. And the method that we need to implement over here is nothing but the run class. So here also you can see we have to implement the run class to implement the multi-threading program. So the actual implementation of the run method will be same for both type of implementation, whether we are extending a thread class or we are implementing a runnable class. So we'll copy paste the same code from here to here and let's uncomment this thing. So we are done with the multi-threaded application, but the way we call a multi-threaded program by implementing the runnable class is somewhat different with the previous approach. And let's see the way we do it over here. Instead of calling the kitchen.class, what we do, we create a thread object over here. So let's create an object called as thread. And within this thread class, we have to pass a runnable object. And the runnable object is nothing but a class which have implemented the runnable method. So over here, the runnable method has been implemented by the kitchen class. So what we'll do, we will pass the object of kitchen class over here. And that's it. And here what we have to do, to execute this thread, we have to just simply do thread.start. So the way of invoking the thread in both the way are more or less similar, only there is a few changes in the code. So let's do the same thing over here. And thus we are done with our multi-threaded application using the Runnable interface. So I hope you are clear with both the way of implementing a thread class into our program. So let's run it and we will definitely see a same type of execution also over here. So here also you can see all the three threads have started working together and two of them have entered the critical section together. One of them has started preparing the food, that is the thread 2. And after that another thread have taken the order, started the food, and all these things have taken place over here. So the way the program has been executed by both the approach is pretty similar. So it doesn't matter for a simple program that whether you are invoking a thread class by implementing a runnable method or by extending a thread class. But there is a pros and cons that you have to understand while implementing a multi-threading application. Because in interview, most of the time, an interviewer will ask you that if we can create a multi-threading application by both extending and by implementing a thread and the runnable class, then which one is better to implement and why should we take that approach into consideration? So we will answer this question now. So if you know, Java doesn't support multiple inheritance, which means that if we are extending the thread class, we are not allowed to extend any more classes over here. So if your program demands that your subclass needs to extend any of the parent class, then we cannot go with this approach of extending a thread class. But at that time, what we have to do, we have to go with the concept of implementation. Because over here, with the help of the implements keyword, we can add multiple number of classes in our implements list. And that is the only reason why we should go with the implements way rather than the extending way of creation of the thread. So I hope you are clear that why we are going with the implements way of creating the thread rather than extending the thread class. So if you have any doubt, do let me know in the comment section below. I will be happy to help you over there. So here, since we are done with the basic of the multi-threading and right now you know how to create a multi-threaded application in our system, in our next video over there we will be solving the problem that we are facing over here, which means that the two of the thread should not start preparing the food simultaneously. One thread should wait for the critical section to get executed, and after that only another thread should enter the kitchen. And that problem we will be solving it in our next video. So if you are keen to know how to do that, do subscribe to my channel and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So without wasting much time, let's go to our next video where we will be implementing the synchronization among the threads. So see you on our next video. Thank you.